Today we are going to talk about Armstrong number. We must understand what is meant by Armstrong number. So Armstrong number is a number in which when we perform addition of cube of the digits and that addition is equal to the same number, then we call that number as Armstrong number. So what is Armstrong number? The sum of cube of digits of any number is equal to the same number, then we call it as a Armstrong number. Now let's take example. I have a number 123 for example. So sum of cube of, so 1 raised to 3 plus 2 raised to 3 plus 3 raised to 3, that's the sum of cube. So cube, 1 cube is 1, 2 cube is 8 and 3 cube is 27. The addition comes to be 34. So whether 123 is equal to 34? Answer is no. It means that 123 is not a Armstrong number. Then next example, 153. So in this 153, my first digit is 1. So 1 cube is 1. Now I am not writing 1 raised to 3. 1 cube is 1. 5 cube is 120 and 3 cube is 27. So when we perform the addition, it is 125. Sorry. Okay. So 1 cube is 1. 5 cube is 125 and 3 cube is 27. So when we perform addition of these, the result is 153. So original number is 153. The sum of cube of the digits is also 153. That's why 153 is called as Armstrong number. Is this clear? Now in logic, what we have to use? In logic we have to first separate the digit, and then we have to perform in second step the obtain the cube of each digit, and then sum of the cubes of digit. Then we are going to get a result. That result is nothing but sum of the cube, and that we have to equate with the original number. So that is going to become, that is a test whether your original number is equal to the result. Result is what? The sum of cube of the digits. That is the result, right? So this is what we have to do. Is this clear? What we have to do? Fine. Now how to do this? For that purpose, we have to, first task that we have to do is separate the digit. So how to separate the digit? That can be done by using modulus operator. So we need to use modulus operator along with the division operator, integer division operator. So division operator, normal, right? In that case, we will be getting a remainder, that is a digit in the number, and then we will also reduce that number by 1. Why? Because it requires for our let's say problem statement. So let me show you how I'm going to do this. So 153 is my number, right? So let my n is equal to 153. Now in this 153, first task that I'm going to do is going to find the remainder. So remainder is equal to what? N mod 10. So in that case, the result that I'm going to get is 3. I hope everyone knows the meaning of remainder. So n mod 10, that is what we are going to get answer as 3. That is my first digit. So I'm going to find one variable as result, and initially that result is 0. So result is equal to result plus rem cube. So rem into rem into rem. So remainder into remainder into remainder. That is going to give me its cube. Right? So this is what I'm going to perform for first number. Now my number, that is n, should become 15 because I want second digit 5, right? So remembering the logic that we have seen, what we are going to do, we are going to perform n is equal to n divided by 10. So here, as my number is 153 and I am performing division it by 10, we know that in integer division, part after decimal is dropped. So actual answer is 15.3, right? That is a float division basically. So in integer division, the part after decimal will be dropped. And what we are going to get? We are going to get 15 as the answer. So my next number becomes 15. Again, when I perform here in second iteration, remainder is equal to n. N current value is 15. So in this case, in case of second turn, so second iteration, we will get n as 15 mod 10. So remainder in this case will be 5. And then as remainder is 5, result previously that we have calculated is 3 into 3 into 3, that is 27. So 27 is the current value of result. That 27 plus 5 into 5 into 5, that becomes 125. So my answer comes to be 152 at iteration number 2. Then in iteration number 2 itself, we have n as 15. So 15 divided by 10, again integer division, that will yield as number 1. 1.5, part after decimal will be dropped, answer will be 1. Right? Now again in iteration number 3, we will go again up because we have to do the same task again and again. So iteration number 3, in iteration number 3, my current value of n is 1. So when I am going to perform 1 mod 10, so the result will be 1. See here, division will be of 0, 1 will be the remainder. So current value of remainder is 1 and current value of result, RES, is 152. So 152 plus 1 into 1 into 1, that is 1. So 152 plus 1, how much? 153. 1, that is equal to 153. And now finally what we are going to do, at iteration 3, we are going to have 1, that is current value of n. So 1 divided by 10, that is 0.1. Part of the decimal will be dropped. So answer will be 0. That means finally I am going to get answer for this as equal to 0. So when my numbers become 0, when my n becomes 0, my loop should get stopped. That is nothing but my loop stopping condition. Is this clear? That is what logic we are going to use to check whether my whatever result finally I am going to get, that result is Armstrong or not. So I am going to get result here, that is addition of cube of that 3 digits number, and now finally we will perform result is equal to original number or not. So let's go for the demo now. Okay. So let's open Turbo C and then we will create a new file, new. Let's save the file with F2 and let's give name to this file as Armstrong. So I'm just giving name it as armstr.c. So this is what my file for Armstrong number, right? So let's give comment to this program as program for Armstrong. Right? So let's begin. As our practice, we include what? Header files. So 2 header files we will add in our program, and then after that we will begin with void main. Let's begin. Most importantly, we must think before we start writing anything in the program, what should be the variables that I need, right? So I need integer type of variables. The number 1 variable is my number itself, okay? Then second, listen carefully. When I'm going to perform number divided by 10, the number is going to change, right? And at the end, I have to equate or I have to compare my original number with the sum of the cube of the digits. So my original number is getting changed. So I need to have its a copy, temporary copy, to which I can compare. Is this clear? So for that purpose, we are taking one more variable as original number, or let me call it as temp number. Temp number. Okay, so temp number. Then as we are going to find out remainder, so to save the remainder, we need a variable that is rem, and then after that we need sum of cube. What we need? Sum of cube. So when we are going to find cube and then sum, we need to save that sum somewhere. So let's call it as result. Now listen carefully. We are going to perform result is equal to result plus remainder into remainder. So when we are adding value in a result, it means that the initial value of the result should be 0. Otherwise, when we declare the variable, we know that there is garbage value in C. In case of C, when variable is not initialized, its content is garbage. So we are going to do res is equal to 0. Is this clear? So that is all variable that we need. If we are not getting how many or what kind of variables we need at the beginning of the program, it's okay, no issues. Whenever you feel I need one more variable, come to the declaration section, declare that variable and start writing your program. Is this clear? In case of C programming, you cannot declare your variable anywhere. You have to declare your variable in the beginning of the program. Is this clear? That is the main compulsion in C programming. Now let's begin. So let me do CLR SCR first. Okay, so CLR SCR is for clearing the screen, as we know, and then after that we will give message to the user that he has to enter what? Enter a number to check whether it is Armstrong or not. So user will get the message and user will give a number to us. So to accept that number, we are going to use scanf statement. So scanf, the format specifier for that number is %d, and save that number at an address of number. Once the number is accepted, we are going to make its copy in temp number. So temp underscore number is equal to number, original number. So now here we have 2 copies of the original number. Everyone understood? One copy is going to become 0. One copy is eventually going to become 0. And now that is what our stopping condition should be. So unless my number is not 0, perform the operations again and again. When my numbers become 0, stop performing that operations. That is what my termination condition. Now, one important thing. When we don't know how many times the number of iterations are going to take place, in that case we go for while loop. Here we don't know. If user gives 3-digit number, then maybe 3 iterations, 4 iterations. If user gives 5-digit number, then 6-7 iterations. If user gives 10-digit number, then number of iterations may change. So number of iterations may change. So for that purpose, what we are going to do, we are going to use here while loop. So I am writing here while what? My temp number is greater than or equal to, so let's say greater than 0. My temp underscore number is greater than 0. So till that number is greater than 0, perform what? This block of code we have to execute. So what we are going to do in this block of code? The same 3 operations that we perform. Finding remainder, finding the value of result, and finding the new value of the number. Right? So first we will do rem, remainder is equal to remainder is equal to number, that is temp underscore number divided mod 10. So here we are going to get first remainder number, and then we are going to perform result, result is equal to result plus, see here, rem into rem. So when we are going to perform rem into rem, that means the whatever remainder number we are getting, that single digit, we are obtaining its cube, and that cube we are going to add again and again with the cube of next digit number, whatever we have. Okay, once we have got this result, then after that we will go for reducing the number by one digit, and that is obtained as, let's say, temp underscore number is equal to temp underscore number divided by 10. My number is going to be reduced by one digit. That's it. Now after end of this while loop, we will get the temp number as 0. Temp number will become 0. However, res, result variable, whatever this result variable we have, that result variable will have the sum of addition of cube of the digit. Sum of the cube of the digit. That is what we are going to have at the end. So here we need to use if statement. Here we need to use if statement. So what in if we are going to write? If our original number is equal to result. So if it is like that, then we will give a message. What message we will give? Printf, we will give message as the number is percent number is, whatever number we have given is, that number is Armstrong. Now that number is coming from number, or you can also print the value of result. Both are same. And if what, that number is not equal to result, then in that case we will go in else, and in else we will give the same message, but what the message is? %d number is not Armstrong. And it is coming from number. Let's close this. Let's done this. Is this clear? After print we have forgot to give semicolon. Okay, so everything is okay. Let's compile the program with F9. We will compile the program. There is no any error, no any warning. Before running the program, okay, let's run the program first. Control F9, enter the number. So I'm giving 123 as input. Okay, I forgot to give get ch, so let me write here get ch at the end, so that we can get the output screen. Okay, and let's run it again. Control, give the number input as 153. 153 number is Armstrong. Is this clear to everyone? Yes, fine. So let's see the same with output window and which watch variable. Let's analyze the program again. So we will analyze program again with watch window, and which variables we have to watch? We have to watch, see here, number first, then we have to watch temp number, then we have to watch our remainder, then we have to watch the result. So these many variables we have to watch. Okay, now we will compile the program line by line. So how to compile program line by line? With F7, right? So let me do F7. Program started. Observe everyone, watch window. All variable contains what? The garbage values, right? So as soon as first statement get executed, result value should become 0. So result is 0. Watch the output screen which has some content, right? After CLR SCR, it will get clear. Now we will get a message. We will get a number as 153. Okay. So now see the value of number, that is 153. Currently temporary number contains the garbage value. When the current highlighted statement will get executed, then the value of num and temp num will become same. So are they same? Yes. Now while temp underscore num is greater than 0, so condition is true. So when condition is true, it will enter in the loop. It will change the value of remainder. Now see, the remainder value is garbage. In watch, see, it's garbage. Now it is going to change and it is going to become 3. Alright. So result contains 0. So result will be result plus, that is 0 plus 3 into 3 into 3, that is 27. So got there? Result 27. Everyone watch the watch window also. Okay. Now while again we will go back to the loop, and here the condition will be checked as temporary number. See, temporary number is 15. That number is greater than 0. Again loop will be executed. Now see, remainder will be now 5. Now result will be 125 plus 27, that is 152. Now temporary number will be 15 divided by 10. Result will be 1. So see here, temp number is 1. Now temp number as it is 1 which is greater than 0, loop will execute because condition is true. Now 1 mod 10, result will be 1, so remainder will contain 1, and now result will be 1 plus 152, that is 153. Now temp number is 1 divided by 10, we are going to get result as 0. Now the condition will become false because 0 is not greater than 0. 0 is equal to 0. So now loop will break and the flow of execution will jump after the block of while loop. And then the condition will be checked whether num is equal to result. See the value of num and result in watch window. Are they same? Yes. So this statement, that is %d number is Armstrong, that will be printed on the screen. 153 number is Armstrong. And then get ch will bring output screen in front of us, and that is the end of the program.